The previous chapter, we did a ton of simplifying or expanding logarithms using the log laws, but I did end saying that solving is for me, the most important part of using logarithms. Finding an equation that has an x somewhere in the exponent and being able to bring it down below and actually solve for it and find an answer. To me, that's really important. Now, there's two types of solving questions, which is why there's two chapters. So we've got chapter 2. I guess, whatever it is, solving with logarithms. So you can look, sure enough, inside the equation, there's logarithms. So you're solving logs. There's log questions. Then there is questions that say solving exponents. Look at all of these. The exponents are all unknowns. So we're going to use logarithms. So there's two types. Ones where there's logarithms in the questions, like this, and ones where we're going to need to use logarithms to solve. So chapter 2, chapter 3, both really, really important. You're going to use some of chapter 1 in all of these, actually. So for this type of question, the idea here, and I've kind of written it here, is to reduce to single logs on each side and then remove the logarithms. So for instance, take a look, even the second one, there's two logarithms on the side. We're going to use log laws and we're going to put them together. So the idea is you want to get a log on one side and a log on the other side. In fact, you can even see this here. If we have log A and you have log A, if they're both already done, then really the question becomes just P equals Q. These kind of are gone, and all you're left with is P equals Q. So our goal is to make them logs on both sides, and single logs on both sides. So let's do that here. One of the things that you have to do first, if there's ever a number in front, you're going to need to get that exponent and bring it up. So really this is a log 4 of x squared equals log 4 of 25. And what's odd now is just algebraically what we can do is we can say, well, let's write this as 4 to the power of log 4 of x squared and 4 to the power of log 4 of 25. And what will happen is these things will cancel out. In fact, I brought just a calculator here, and let's just try it. So you can go, if I can actually turn on a digital calculator, apparently that's difficult. 4 to the power of log base 4 of 25. So the 4 and the log 4 will cancel out, leaving only the 25. So that's what ends up happening. These will cancel, and these will cancel. So you're left with x squared equals 25. Now I'm going to bring that up here and continue working on that. X squared equals 25. Now you can get the x alone, so you can square root both sides. So you get x is equal to square root 25 is 5, but there's a plus and a minus. So really you're left with a plus 5 and a negative 5. Those are our two answers. Now one of the things that you have to remember is that, and maybe you can write this somewhere, it doesn't matter what base it is, so log a of x, whenever you have that, x has to be bigger than 0. It can't even be 0, meaning x has to be positive. That is always true. X has to be positive. So whatever's inside here has to be positive. So if I take negative 5 and I put it in here, what do I get? Well, I get just negative 5, and I'm not allowed to have that. If I take positive 5 and I throw it in here, this thing becomes a positive 5. And so I have to reject this one. Therefore, you only actually have x is equal to 5. Now, just keep in mind, just because it's negative doesn't mean that it will, you have to reject it. You actually have to plug it in. So say, for instance, it was like that. You would take negative 5, you go negative 5 minus 2 is negative 7. Well, negative 7 is negative, therefore it fails that. And then you would look here, oh, well, put negative 5 in there, it still is a negative 5, and it fails there too. It fails twice. But sometimes you're going to have things that like log of 10 minus x. And then you take negative 5 and you throw it into here, and it becomes 10 minus negative 5. That's a plus. That becomes a 15, and that's okay. So keep in mind that just because it's a negative doesn't mean that it's automatically rejected. You actually have to plug it into the inside there and just make sure you don't have a negative number. Okay, so let's try b here. Well, actually, I'll just let you take a look at a in case you want to copy that down. So I'll do b here. We got to combine these. There's no numbers in front that we need to bring up, so we can combine these. So this is a log base 2. This is using our log law. Because we're adding, you can actually multiply. So you can go x minus 2 times x. And log base 2 of 3 is on the right. Now I can actually combine these to get an x squared minus, so I can FOIL that in, expand it in, x squared minus 2x. Now I'm actually going to go 2 to the power of and 2 to the power of, because that will cancel with that and that will cancel with that. And I'm just left with the x squared minus 2x is equal to 3. And then we can move the 3 over. So x squared minus 2x minus 3 is equal to 0. So whenever you have a quadratic where x squared and an x, you got a trinomial, you can factor, or you can try to factor. If not, you can use the quadratic formula. Now, I'm actually going to factor this thing. So that's an x and an x, that's a 3 and a 1, and one of them has to be negative. That'll make negative. So that's a 1x. That's a negative 3x. If I added those, I get a negative 2x, which is good. That is my middle term. If you don't recognize what I'm doing here when I'm factoring, I'm sorry, you're going to have to look up how to factor something, and if you learned a different method. So this thing factors to this. So then I have two things to solve. I have x minus 3 is equal to 0, or I have an x plus 1 equals 0. And those are really easy questions to solve. I can bring the 3 over. So I get x equals 3. And I can minus the 1 over. So x equals negative 1. So those are my two answers. So how did I do that again? Well, first I brought these two together, which allowed me to multiply them to get an x squared minus 2x. Now they're a single log, so I went 2 to the power of that and 2 to the power of that to allow me, that's the algebra that allows me to kind of eliminate those. Then I can move over the 3, solve by factoring here. Alternatively, you could use a quadratic formula. And I got two answers that I need to check. So I put 3 into here. So 3 minus 2 is 1. That's a positive number. Beautiful. Put 3 into here. Well, that's a 3. That's a positive number. So that one works. Put negative 1 into here. What do you get? Just negative 1. Oh, it automatically fails. I don't even need to check the other one. That's a reject. I automatically can just reject it because it fails there. Just out of curiosity, would it fail in this one? Negative 1 minus 2 is negative 3. It's also a negative number, so yes, it would have failed in there as well. But I just need one failure. Okay, so that's the end of this video. We're going to do the other questions. We'll do those in the next one. But I think we don't have, yeah, no, we do seem to have a lot here. They will get definitely more complicated as we move forward, but I want to do a new video because these are odd. You've never maybe, I would imagine you've never seen the natural logarithm before. So that's what we're going to do next.